Using the figures 68%, 95% and 99.7% for within 1 standard deviation, 2 standard deviations and 3 standard deviations of the mean respectively, find the following for the distribution given here. And we can see that the mean is 100 and the standard deviation is 15. So if we start with part A, and this is 100, and if we go here, that's 85, and here is 115, then we can see that that's minus 1 standard deviation, this is plus 1 standard deviation. Within 1 standard deviation, we know that's 68%, so the probability is 0.68. So let's look at B, which is from 85 to 130. So let's draw the distribution. So 85 is here, 130 is over here. Now, this is minus 1 standard deviation. This is 2 standard deviations above. So we're going to want this area added to this area just here. Now, that's half of this area. The area is 0.68 here, so that one is 0.34. That's half of the 2 standard deviation area, which is 0.95. And so that's going to be 0.95 divided by 2. So 0.34 plus 0.475. That's going to give me 0.815 there. Okay. Part C, just greater than 145. So 145 is over here, and that's plus 3 standard deviations. And if we're greater than that, we want the area down there. Now, if we were to go symmetrically to the other side, we know that 99.7% is in here. So 0.3% is in the 2 ends added together. So 0.15% is what's in the required region. And so 0.15, divide that by 100 and we get 0.0015. Finally, we want the probability that x is greater than 145, given that x is greater than 130. Now that's a conditional probability. Probability of A given B is equal to the probability of A and B divided by the probability of B. So, in other words, we want both conditions applying. Well, if it's greater than 145 and greater than 130, both of them is when it's greater than 145. And greater than 130 would be on the bottom. Greater than 145, we've just done. It's 0.0015. So for 2 standard deviations to be above that, greater than 130 would be this area over here if we look at this diagram. And we can do a similar sort of thing we did over here. So if we had the symmetric area down here, because we know in between those we have 95%, that means 5% is distributed between the 2 ends. So just the one end here is 2.5%, which is 0. So 2.5% divided by 100, 0.025. So if we multiply top and bottom by 10,000, we'll get 15 over 250. Both of those divide by 5, so that's 3 over 50, or 0.06, because this would be 6 over 100